Hello, I'm Keith Carlock from Owensboro, Kentucky. This is a model I made a few nights ago, a three-dimensional multiplication cube. Um, uh, the name I give it is a magic, because I don't know of any use for it just yet, but I think I might have a clue. I call it a magic interval matrix cube in a multiplication form because all these numbers are derived from multiplication. There's another type of cube, an addition form, because the same numbers, the same basic um, six numbers around a three axis put together of squares, of magic squares, are put together with addition to derive um, sums of numbers. And for right now, the addition squares and cubes don't have the proportions that a multiplication square and cube does. And that's where I think there's a problem in finding the goal. The goal that I wanted to say is that the ultimate goal is to find the ghost corners or the floating corners, the ghost numbers in the floating corners. If I could give you an example of what this is, I see this as sort of a matrix, an interval matrix of reality. There's three different planes, three different orthogonal planes to each other, um, three different squares put together, and you'll see examples in this article of what the squares are, and it's three separate squares put together with their four numbers on each side combined to create the six numbers. I believe it's six numbers. One, two, three, four, five, six numbers that are done with multiplication or addition. Multiplication, I compare to the Cleopatra because it's more beautiful. I guess it makes more sense. The addition I compare to Frankenstein because it has a bunch of just different weird relationships with each other, and some not even just relationships, just statements of values or something. But this is the inner square, the inner cube made up of three squares. It has its own floating floating corner, because it's not part of the three axes that make up the cube itself. It's like floating off of the axis of reality, if you can compare it to reality. All these 8 open sections on all sides of the cube, the inner cube as well as the outer cube, they're all floating corners. And the thing that goes there is the ghost number, because it's like a ghost floating off the corner of reality. All these other numbers are on their corners. These are not the actual real corners of a cube. These are not the actual real corners of the outer cube. The real corner is this ghost, this floating corner, where the ghost number goes. I call it a ghost number. It's a floating number. It's in the floating corner off the grid of reality, off the three orthogonal axes of reality. And this could be represented of a matrix in quantum mechanics that Heisenberg inadvertently stumbled upon, that Max Born figured out, and there was already the well-known math of matrices. And my goal, it's easy enough to find the corner angles, the corner numbers on a square. The corner numbers, you simply add the horizontal and the vertical numbers that are there in the middle one, in the center one, and in the outside one, and you add up to the corners. Like for instance, 3 times 8, and the multiplication is 24. And it's easy to find proportions and everything, and that creates the interval expression that's always true I call it a pseudo-interval expression because I don't see how a real interval expression could be derived from there, but it's still always true and it's meant for something, because the greater than less than signs of the interval expression of a square becomes some weird belt-like structure, and you'll see a picture of that in this article too. But again, back to these corners, these ghost corners, these floating corners, where the corner should be an actual corner to the grid, to the cube. That's where the ghost number should be. And to determine the ghost number, you would go along the diagonal. This diagonal right here that's composed of the what I call the three outward facing numbers, the points at the edge of these grids of these three axes, these numbers. That has a number, this has a number, and that has a number. And also some sort of combination of the three inland numbers. The number up here, which is 8, the number and the numbers right here, which is 3 and 3. And they have to have some relation diagonally to the opening space below it diagonally. Those numbers below it have to have a relation to the ones that, at this space, to create two like numbers going across, ghost numbers at this corner on top and at the corner diagonally down from it behind it. Therefore the big ghost number that are the same, just like on the square where you have two numbers the same that are the products of the inner numbers, but these are composed of an array of numbers that I have a hard time figuring out. And my guess is that maybe when I figure out the relationships of the addition squares, I can put them together into a cube with a meaningful circling instead of just circling the smallest terms of an addition. They'll actually have some meaning, and they would probably add more to the significance of the inward and outward laying numbers, 3 number sets of each opening, each ghost corner, or each floating corner where the ghost number goes. And you could probably somehow use that insight to develop a connection between the top diagonal and the back diagonal on each side of a cube. And all these numbers should be the same. They should be the same. They have different, already checked, they have different numbers for each diagonal of the ghost cube or whatever. But they should all be the same, just like all along of a square. Each at the corners, they're all the same. Like this is 24, this is 24, and down here at this axis, this horizontal axis is all 9s at the corners. They should all be the same around this ghost cube, around the ghost floating corners, or floating corners where the ghost numbers go. The ghost numbers should all be the same. And what I compare the ghost number to is a matrix type of way of invisibility, like you've seen with my other stuff on invisibility. You're sending light through an object. Well, the light is going through, the numbers are going through this object. The numbers, the ghost numbers. If you can compare the ghost number here to the ghost number at the diagonal, its corresponding diagonal behind it, the opening, the the floating corner, the ghost number in the floating corner, you can compare that to the number, the ghost number up here, going through here and coming down here. And if you compare this inner cube to the interface of my previous work in light visual invisibility, you can compare this to the interface of a matrix. This is the inner matrix, the inner interface, the number interface, if you will. My guess is that when you solve for the diagonals, much that you solve for the diagonals in a quantum matrix mechanics, when you solve for the diagonals like Heisenberg or Born did, when you solve for these diagonals, you'll derive the factor of the two factors that are derived from solving matrices where they don't have the commutative property. This does. The inner workings of my matrices does have a commutative property, but the outside, the comparison of a P and Q matrix, one being the momentum, one being the position, P and Q. They're non-commutative, but I believe that since the interior of this matrix is commutative, um, it uses commutative properties to get the numbers on both sides. Like in the inner one, 3 times 1 is 3 on the outside cube, just like 1 times 3 is 3 on the outside cube on the other side. That's the commutative property of this. So of this cube. So this is the opposite of a Heisenberg matrix. It has commutative properties, but in and of itself, in its interior. The outside of two matrices put together in a Heisenberg multiplication to solve for the spectrum of hydrogen in the excited states, they're non-commutative. They can't. One is forsaken for the other, position or momentum, but you can solve like for the diagonals. And the diagonals determine the position and momentum of the array of elements in a Heisenberg matrix. So if you compare that diagonal to this ghost cube diagonal, once you solve for the diagonal, you should derive a factor of the the Planck constant, which I'm not sure exactly what that is, but I do know that you'd also derive the imaginary number I. I believe my guess is that once you solve all these calculations, you'll derive something of the ghost numbers being I itself being an imaginary number, or invisibility, the ability to produce a ghost number. You're essentially writing, I believe, the ghost numbers on the outside of these floating corners, and the interior interface, the number interface is what I call it. I believe those numbers, the ghost numbers, are going to be they're going to be imaginary numbers, because you're numerically sending numbers through this matrix, through the diagonals, like you saw for the diagonals in a Heisenberg matrix. So I hope the rest of my article, I'm doing that tonight, I hope the rest of my article explains this more clearly, but I hope this gives you a visual of how this is a whole lot like my light interface. There's an interface inside, takes the same shape as the object you want to make invisible, and sending light through a plane in our reality is like having the multiplication, the product, equaling the multiplication. I forget what the name of the multiplication. The multiplicatives at the corners of the inner cube. You have the product 24 up here, and at the other axis, at the other diagonal, you have a 24. And likewise on these, the other diagonal of the square is 24. And but it's changed on here, but they're none at these diagonals. And so there's got to be a ghost number at the floating corners that I believe will be imaginary numbers. I don't know what the Planck constant would be. I think it would be the fact that light would be sent through, or numbers would be sent through. But this is an idea. It's a strange concept of sending numbers through an object. But you're sending numbers through a matrix, or you're solving for the diagonal of this ghost cube. The ghost cube with the ghost numbers at the floating corners. I call them floating because they're not actually there. They don't exist in the three planes of our physical reality. They exist at a ghost corner. This could be likened to a Hilbert space, where the ghost corner is the extra dimensions. The ghost corner or the floating corner where the ghost numbers go on all 8 openings of this, the ghost corner. So this is my idea, and hopefully I explained this, and hopefully I made the analogy to physical light interface, with the inner cube being the light, being the number interface, where the diagonals, somehow the inlaying and outlaying numbers some combination of these and down here that I believe must be solved um, from the squares, from the addition squares having some sort of relationship bearing to equal to the proportions on the lines you solve around a multiplication. The Frankenstein has to be more like Cleopatra, and in order to develop some insight to add these numbers together, these arrays of numbers up here and the arrays of numbers at a diagonal behind it at every opening. And I believe the product would be an imaginary number of some sort, because you're sending numbers through the matrix. You're solving the diagonal of a ghost cube. I think I said what all I had to say, so this is one last picture of it. I'm very proud of this, by the way. This is a multiplication cube. When I get the material, I'm going to make an addition cube and look at these and study these and try to figure out how to send a number through a matrix by solving for the diagonals. So thanks a lot. Bye bye.